first thing we want to do is we want to identify what is the length of the period, and that is the length of the interval of one cycle. Remember that our traditional sine makes the shape of a hill and then a valley. So to figure that out, I'm going to start by circling whatever's directly in front of the x. And I'm going to take 2 pi, and we do this for both sine and for cosine. We take 2 pi and we divide it by whatever is directly in front or attached to the x. Now, when I divide fractions, I turn division into multiplying and I flip it. And now you can see I end up with 8 pi over pi. Well, the pi's are going to be simplified into 1, and I'm left with simply 8. So both sine, cosine, and tangent are all 4 steps. All these periodic functions are 4 steps or 4 units. So in 4 units, I'm going to make 1 cycle. So 1 cycle will be completed in 4 units, and that takes a length of 8. Just like your homework, we're going to do a total of 2 cycles to the right, so a maximum of 2 cycles to the right and 1 cycle to the left. So if 1 cycle to the right is 8, I can easily say I know 2 cycles is 16. There's something called an x scale you learned about. An x scale is what is the length of one of these units, or I refer to them as steps. In order to figure that out, we take this and we divide it by how many units? Well, there's 4, because there's 4 steps. So I take 8, I'm going to divide 8 by 4, and I end up with 2. So this is 2. Here's another 2. 2 plus 2 is 4, plus 2 is 6. And you can see this happens to be a very easy one. Now, when I go to the left, I'm going to go just like we think of an x-axis. This is going to be -2, -4, -6, and -8. So the 2 things I've done right now is I've identified what is the length of the period and what is the length of 1 step or 1 unit. Okay, now it's time to begin working through this. Okay, now it's time. So I want you to take out your unit circle if you happen to have it. Take out your unit circle. So here's how we're going about doing it. I'm going to take this first step and I'm going to plug it in. So, and you can do this mentally, but let me write it up here. So I have y equals 3 times the sine of pi over 4, and now I'm going to replace the x with 2. So this becomes 2 pi over 4. Now I know 2 pi over 4 reduces to 1 pi over 2. So I want to ask myself, if I want to evaluate what is the sine at pi over 2. So let me bring this picture back up. Here is pi over 2. Remember, it's cosine followed by sine. So the sine at pi over 2 is 1. That means that this portion is equivalent to 1. 3 times 1 is 3. So I'm going to go up 3. 1, 2, 3, and I make my mark. Now we can also do 0 here. I guess I should not have skipped that. If I do the exact same thing with 0 and I replace 2 with 0, 0 times pi over 4 is simply 0. So let's evaluate the sine at 0. I'm going to come back here. Let's evaluate the sine at 0. The sine at 0 is simply 0. And when I take 0 times 3, I get 0. Then I'm going to plug in 4. The next thing I'm going to do is I'm going to plug in 4. So I'm just being lazy here, but I'm going to replace 4 up here. So I have 4 pi over 4, 4 pi over 4. Well, the 4's are going to reduce to 1, and I want to evaluate what is the sine at pi. What is the sine at pi? So I come back here. The sine at pi, we can see right here, is 0. The sine at pi is 0. And so 0 times 3 is simply 0. Can I have a thumbs up or a thumbs down if you're understanding how I'm doing this? Okay. And then I would go ahead and I'm going to do one more. So I'm going to do 6. I plug in 6. So I have 3 sine of pi over 4 times 6. When I reduce this, I get 3 pi over 2. I want to know what is the sine at 3 pi over 2. So I come back here. Here's 3 pi over 2. The sine is -1. So -1 times 3 is in fact -3. And you would see that I get this exact same cycle. So this is one cycle, and that exact same cycle I can now repeat, making my dots, as I said in the video, instead of just making the wave curve and hoping you get it right.